So, everyone, thank you so much for joining us at the engineering stage for Rail Live 2024. The first thing to say is there has been a little bit of rearranging thanks to the general election announcement. So our schedule, a little bit of juggling here and there. So if there's anything that's not quite as you expected, that is why. So you can direct your ire in that direction. I have to firstly say as well, absolutely massive thanks to Pandrel for supporting this, the engineering stage this year. It's a new thing. We're trying out a new event, bringing in sort of more technical, chewy discussions, if you like, about some of the subjects that are important to everyone who is attending and to the wider industry. For the first session today, I'm absolutely delighted to be joined by Stephen Barber,
hello,
the Chief Executive Officer of the Permanent Way Institution, past president, former professional head of track for TfL, very, very extensive technical experience. Absolute pleasure to have you, Stephen. Thank you so much.
It's a delightful to be here and to be chatting to you, Gareth.
Yeah, so we are starting the 2 days of sessions with a discussion about the most, unmitigated, most important thing of everything, which is climate change, global warming, global heating, call it whatever you want to call it. The reality, this is Rail Live, which means stuff has to happen. So we have some digging and rail vacs going on outside. We can hear each other, which is the important thing.
Yes.
So, global heating is a major existential crisis for humanity at large, but it's also a significant challenge for the rail industry. And understanding those challenges is critical in us understanding what choices we need to make. So there's a lot for us to kind of consider. But I suppose I wanted to start with a bit of a discussion on what does the impact of climate change look like on the railway and on the bits that form the railway. Both, Permanent Way Institution covers the infrastructure of the railway, track, overhead electrification, civil engineering elements, but also on the railway at large. But then I think we'll then kind of move towards understanding how we respond to climate change proactively as well, and some of those proactive decisions we can make. So I'll start by sort of saying, well, the railway faces challenges directly from heat. That's the obvious one, but perhaps lesser known are things like additional rainfall, extremes of rainfall, potentially still extremes of cold, although to a lesser extent. They often call it global weirding, where you have not just the heat, but also you have extremes of cold being pushed down by weather patterns. So it's not just the case that as track engineers have to deal with railway buckling. No, there's more to it than that. So I suppose one of the things we could start with talking about is what are some of those broad changes we expect the railway to be facing in terms of the impacts of that changing climate in the UK?
Yes, I think in overall terms, Gareth, you've sort of summarised the position quite well. Water is probably the infrastructure engineer's biggest enemy, and we're going to see more of it, and we're going to see more of it coming in heavier bursts. And our railways weren't all designed to cope with that. Some of them were, but we've got to rethink our railway infrastructure so that it's able to cope, so that it's resilient against some of these events. And where we can't make it resilient, we need to have strategies that enable us to take remedial action or mitigating action to keep everything safe and to the greatest extent possible to keep it functioning and performing. So I know that heat is an issue.
To an extent, we've got an understanding of that.
To some extent, yeah, because we have had high temperatures in the past, and buckling risk has been, I suppose, one of the top risks that track engineers have been managing for decades. We have quite a good understanding of it, and we know the levers we can pull to change it, and I don't think it should be heat itself in terms of track shouldn't be a major issue. I think the variability of climate is a bigger issue, and I think heat in other areas. We touched on electrical equipment earlier on when we were chatting, and keeping electrical equipment cool. Yeah. Is a major challenge.
Yeah,
it's something the railways have not necessarily always got right, but as temperatures come up, 40-degree air temperatures, then the challenges of keeping things cool becomes significantly greater.
I want to just pick on that for a moment because I think that's really useful for everyone at Rail Live, for lots of the suppliers. we are centralizing the control of our trains. You know, we're having increasing centralization towards railway operating centres and having digital control of railways. We're also having more widgets on track, you know, electrical equipment on track that have lots of obvious benefits. We're also having more batteries appearing, which also respond to heat, often dramatically in the work if you don't get things right. All of these things, as you say, those are for clarity. When we talk about the challenges of the future railway facing, we're actually in a way, by modernising our railway, creating new challenges that we then have to think about tackling. So, you know, we touched on electrical equipment. You know, you have a lot of solid state signalling that needs to be kept within its operating temperature, so you require aircon. Also, the humans that run the railway need to be kept cool and comfortable. If you were having 40-degree days once, twice, 3 more times a year, then aircon systems need to cope with that. So yeah, it's important that, you know, creating these widgets and equipment that we have in the railway, we have to be thinking about that. For the kit that we're putting in the railway now, it has to cope. If you've got a 40-year design life, it has to cope with those extremes.
I mean, there's some really interesting examples if you look abroad. I mean, in Belgium, they have done a similar thing with their control of the railway network as we are doing. They've centralised it. They have the equivalent of integrated electronic control centres. But in Belgium, they've configured the systems so that the network is robust against the loss of one IECC. They can transfer the functionality of that location to another location. So they're building resilience at all levels into the infrastructure.
That's the key. Resilience is that word that we can come back to over and over again. Let me come back to water, because there are lots of suppliers out there, lots of exhibitors today who have got technology related to moving water about in a way that doesn't wreck the railway. I could a long list of names of those suppliers, but there are lots of things that you can go and have a look at that manage drainage. What do you know? We talk. What the challenge with water is keeping it away from the railway and managing it and keeping and managing that.
Managing it when it comes onto the railway. I mean, the railway system is an interesting one. It's not like a road. When rain falls on a road, you expect rain to run off and into a drain somewhere, and to take all the nasty particulates on the road surface with it. But that's another issue. But in a railway, most of our railways still operates in a regime where the rain falls, percolates through the ballast, and then percolates into the ground. The railway is a draining system. There are places where we install drainage, but it's by no means universal throughout the network. And where it's installed are places where water has tended to pond, or large volumes of water have to be handled. We have the technology to deal with most of that. Applying it is actually quite an expensive pastime. And so we've got to be very careful in terms of investment, where we prioritise. We do need a clear view of the high-risk locations. And there's a lot of work that's gone on using the other end of digital technology, looking at catchments and climate, and just sort of monitoring the climate and being able to use weather forecasting models to give pictures of rainfall at ever more discrete, or in pictures of forecast rainfall in ever more discrete blocks, in ever more discrete units, so that you don't end up putting a speed restriction on half of Scotland or half of the west of Scotland because heavy rain's forecast. You actually look at the weather models and you can isolate by sections of route where you think there's going to be, where the model is predicting that there will be an issue, and you can remediate that area or mitigate that area rather than attempting to mitigate the whole network. And these are really encouraging, they're really positive developments. As I say, the other issue with drainage is we've really got to try and use low carbon componentry, recycled plastic componentry. I mean, it's fantastic. There are a lot of suppliers already doing this, and I think it's an opportunity to acknowledge that actually the railway supply industry in general, I think, already pretty much understands the imperatives to reduce embedded carbon and to electrify all aspects of what we're doing. There's been some really great developments over the last 5 to 10 years, things like battery electric tools. things like low carbon concrete
all the
use of recycled plastic. And the industry doesn't need a lecture from me on what they need to be doing, because they're often doing it. What I think they do need is help in terms of where investment is required, because it's all very well to say, well, we need low embedded carbon here and we need low embedded carbon there. But if that means completely re-engineering your production process on the basis of a zero commitment contract, that's not the greatest of investment cases to take to your funder.
The second word that I think is important is commitment. So if resilience is an important word, then commitment is also an important word. I'm going to just pull us back, because I think it's really important to talk. Drainage is a very important part of the railway, but it's a good analogy for lots of other parts. So if we talk about drainage, lots of the things we're talking about also apply to other areas of railway operations. The equation is a complicated one in terms of getting the right solution here, but the engineering component of it isn't. I'd argue that broadly, the engineering element is a solved. We know what good drainage technologies look like.
We do. We understand it from an engineering perspective. We understand how drainage works.
Yeah.
I certainly, my experience at TfL was brilliant, because they have, as an organisation, they have for a long time had a very coherent and grown-up approach to handling large volumes of water that fall on London. I mean, they've been doing catchment assessments and looking at flows by catchment for a long time. They've got some very good models, and those are sort of applied to when looking at renewals and looking at the resilience of drainage systems. I'm not sure that the national network is quite as far advanced as that. Although I'm happy to acknowledge that huge strides are being made, undoubtedly.
Certainly the last 2-3 years, a lot has been happening.
Yeah. But there are some really good models out there. If you want to know how to manage drainage in an urban environment or an urban metro environment, go and talk to TfL, because they do it, and they do it very well.
And also internationally, we at the Permanent Way Institution, which, by the way, we'll say what the Permanent Way Institution is momentarily, because I think it's important we talk about that at the end. But we had, at a recent conference, we had representation from Paris talking about how they're organised, how Paris, and their various metro railways manage these things and manage a very proactive look at the extremes as well, and how they manage those extremes and protection from flooding of the whole Seine going up and everything being inundated.
Yes.
So there's some very interesting stuff out there internationally as well. That's very much not that far afield. That there is a train there, folks, that we can tap into. So we talk about that equation. If the engineering element is reasonably well understood, the challenges then come from the operational side. So things like drainage perhaps more than anything else is very time consuming to install, and therefore track access, as we'll talk about in another session later today, is a very difficult thing to manage. We don't have enough access to the railway to do this stuff, because we want to run more trains rightly, run more trains to solve climate, to reduce carbon emissions, but we need more time on the railway to keep it running more. That becomes more complicated.
It is complicated. For much of the network, there are still significant white periods, or what we call white periods where there are no timetable trains. So for quite a lot of the network, it is still possible to go in for 4 to 6 hours, maybe even 7, 8 hours on a weeknight or at a weekend and do work. The problem becomes doing that work efficiently. And we have a generation of engineers, many of whom have joined the industry mid-career since privatisation, who have not grown up in the discipline of engineering in a possession, delivering in short possessions. And there is, I think there has been an increasing tendency to look at closing the railway to give efficient working, as might be understood in a greenfield situation. I think one of the things we could be doing is looking back maybe at practices in the early 1990s at how to make really, really efficient use of relatively short possessions, without blowing the budget. I think these things are actually doable. Unfortunately, I think there are other parts of the network where we have to acknowledge that we have probably oversold access, that we have not provided enough space to do the required engineering work on a long-term
Yeah,
basis.
yeah.
And I think one of the things that impresses me about Austrian railways is that in their infrastructure, in their asset management strategy, allowing time, allowing enough space to do the work necessary to maintain the asset is an integral part of that strategy, where operations and engineering come together in a way perhaps maybe they do now in the UK, but there's certainly been a period when those two functions have existed at almost sort of opposite ends of the organisation and haven't really spent a lot of time talking to each other. You know, let's run more trains and we'll just leave the engineers will cope somehow. Not actually thinking through, well, actually, if we are going to run trains 24 hours a day, when are we going to do the engineering work? And we saw some of that at the Grey Rig, Lamb Rig issue, derailment, where the high-intensity West Coast Main Line timetable had been introduced, relatively small amount of access time for engineering, and when the access time ran out, somebody made a very bad call about not doing an inspection that should have been done.
This comes to a point which we'll pick up. There's a couple more questions before we pick up, but this comes to a point about what the railway is for and what it needs to achieve, and the reality is about we have limited capacity and we don't have enough capacity for what the railways need to do. And the answer to that isn't, well, then we don't, that's it, we've reached the buffers, as it were, on how much more we need to think bigger. But we'll get there momentarily. I want to stick with thinking about how, you know, going back to our kind of the people at Rail Live today and the solutions they have. There are ways that the widgets, the kit, the equipment, the processes can shift and change to deliver more in less time. And I think part of resilience is how much can we change, how much can we upgrade in as short a time as possible. Both, you know, okay, yes, that generally means cost efficiently as well as a useful side effect, but actually time and resource efficiency, those are critical, and they generally mean safer as well. If you have fewer people involved in installing a thing, then that actually is a good thing in terms of safety as well. So what can be done in terms of, you know, what can suppliers be thinking about in terms of, you know, how, you know, designing their kit against metrics of, you know, what should those metrics be, you know, in terms of, you know, thinking about safety is an obvious given, but, you know, in terms of time installation and what does some of that story look like, do you think?
Well, again, I think there are plenty of suppliers out there who don't need a lecture from me on the subject, but, you know, short setup times is an obvious. Basically, you know, high output, for want of a better expression, equipment, although that seems to be a little unfashionable at the moment for some obscure reason.
Yeah.
But you know, machines and processes and techniques that are capable of delivering large volumes of whatever in relatively small time windows.
So let's pick up on that, actually, because I think that there's a without going into the nuts and bolts of a set of equipment that is specifically called high output, the high output track renewal machines and ballast renewal machines were part of a view of the railway as a long-term asset that requires long-term strategic thinking. Do you see that as a critical component in the railways being resilient? Do you see long-term thinking as being a critical part of that? Do you think that?
Yes,
do you think it is?
It has to be. I mean, you know, coming back even to the point of, you know, the supplier's business models and their investment requirements, that you cannot invest in a rail manufacturing plant, for example, on the basis of, you know, a year or even 5 years orders. You need to understand there's going to be a need for that. You've got to think long term. Railway assets are long-term assets. I mean, when I was at TfL, one of the more sobering thoughts was that most of the track we were installing would still be in there functioning long after I'm dead. So, you know, we were installing track or track systems and track forms which have a life of somewhere between 50, 80 years. I mean, there might be requirements to re-rail within that period, but basically really long-lived assets. And if you've got those assets, you need to think about maintaining them. You need to think about...
That's the timescale you're thinking, right? You're not thinking, you know, even 5 years. Is, you know, if you have an asset there that's 80 years, you have a wider railway corridor that essentially we're expecting to be there for another century or two. and that really only because that's as far as we can realistically think.
And
you have to think.
our predecessors, or me in another life, I suppose, in some respects, we were installing in the 1980s, 1970s, 1980s, we were installing concrete sleeper continuously welded rail, a continuously welded track, and there are many parts of the UK where that track is still in situ, performing very happily. Now, not the fast lines of the West Coast Main Line, not the fast lines of the Great Western Main Line, but if you look around the network, there's an awful lot of 1970s, 1980s infrastructure which is still performing very well and is likely to continue to perform very well for another 20 to 30 years. But it does need looking after. So going back into being a track engineering nerd again, things like rail pads and rail foot insulators between the clips, and those are incredibly important components if you're trying to get the best life and performance out of your asset. And you can't just fit a rail pad at the when you renew the track, first you renew the track and expect it to last for 100 years. It's a wearing component. It will at some point, probably in 20 years' time, require replacement. And if you replace it, the track itself will just live for that much longer. If you don't replace it, you end up with all sorts of problems, including performance issues like broken rails.
Which then eats into the track access
Yes.
that we have then. It's a bit of a. Like, as soon as you start thinking long term, lots of the problems, lots of these microcosm problems start sort of fitting themselves together like a jigsaw puzzle, and things start making a lot more sense. I would like to. So for the last sort of 7 minutes, actually, I'm going to do an interlude because. Let's just explain what the Permanent Way Institution is. So I'm a track engineer by training, and so I'm a proud member of the Permanent Way Institution. What is the Permanent Way Institution?
Well, the Permanent Way Institution was founded in 1884. And when the Permanent Way Institution was founded, there was one infrastructure engineering department. One engineering department looked after everything that didn't move, and another engineering department looked after everything that did move. So the PWI was set up by some people in those engineering organisations who wanted to share knowledge about all forms of railway engineering, fixed asset engineering. Over the years, that really focused down quite heavily on track, particularly with the rise of electrical equipment in signalling in the 1920s. The signalling function became a self-standing function. The IRSE, Institution of Railway Signal Engineers, was established, and so signalling became very much an independent discipline. But pretty much everything else still sat within the ambit of the PWI. As we've gone into the sort of the 90s and 2000s, Permanent Way has increasingly within the industry been seen as track.
Yep.
Whereas at one point, Permanent Way was everything between the fence lines, including the fences. Now it is seen as track. And so our name is really not it doesn't tell the full story, and it's not really appropriate to moving forward, in my view. The members will have doubtless their own views, but we are looking at new name for the institution. But we're really about the railway engineering from a systems approach. So looking at earthworks, drainage, bridges, structures, tunnels, track, electrification, power supply, the whole range of things that need to work together and need to work well at high levels of performance to keep the railway functioning.
Yep.
I don't want to tread on the toes of the railway division of the IMechE. I don't want to tread on the toes of the Institution of Railway Signal Engineers. They have their specialist disciplines. But what we want to provide is an overarching structure within which all those disciplines and interfaces can be thought of in engineering terms.
And we've alluded to it with some of our earlier discussions, is that you have to think systemically, whether it's accessibility, whether it's resilience against the changing climate. You have to think of the system. That makes no sense to think of the railway only as down from the rails. You have to think about the wheel-rail interface. You have to think about those interactions. So that's kind of key. I want us now to, as we kind of come to the last 5 minutes of the session, I want to pick up a chance for a couple of questions as well. Very briefly, there is a big picture about proactively dealing with climate change as well. And we've talked about this. We both care very passionately about this bit of the picture not being ignored or forgotten. So what is that bit of the picture? Capacity is the word I'm driving towards. We've got resilience, commitment, and capacity. What's the capacity bit?
I think it's understanding how we use capacity to best advantage. Railways in the UK, we have a terrible tendency to be introverted, to think about railways as railways and to get very into the detail of railways. And to some extent, from an engineering perspective, you can understand that. But railways are one element within our nation's transport systems. And if we are going to address the challenges of climate change, and particularly the challenges of, what in expert areas, circles, is certainly acknowledged as a long-term shortage of electricity. When we get to 2050, unless we do some really, really radical things, we are going to be very short of electricity. We'll be able to afford to run roughly 60% of our current road transport network electrically because we have no plans to put in place enough generation to power the lot. And there's the weight of vehicles, and there's the battery technology and where all the materials for that are going to come from. So public transport per se, and railways as part of that, have to be part of the answer to global climate change. And if we look abroad, you look at Europe, you look at Switzerland, Austria, Germany, Italy,
Spain.
Spain. These countries they've acknowledged they've got a problem. Germany, they're probably not much more advanced than we are in addressing the problem. Switzerland have spent the last 40 years actually strategically thinking about their transport system, the roles of different modes, and how they provide the right incentives to move the right traffic on the right mode, and hence the percentage of freight transport in Switzerland, which is on the rail network, is something like 6 or 7 times
beaten only by Russia.
It is in the UK. And that hasn't happened by accident. That's happened because successive governments have decided that's where transport policy should take them. I think we need to think about rail in that wider context. It isn't a question of rail versus bus or rail versus coach. It's rail and bus. I spent some of my younger days in a drawing office in the early mid-1970s designing bus turning circles at railway stations, because at that point, pre the sort of great marketisation of the early 80s, at that point, passenger transport executives were very focused on creating integrated transport systems, very much along the same lines that the Swiss were doing. In the 1980s, we blew that apart. Bus privatisation has, I think, reasonably acknowledged now has been a bit of a disaster for the bus industry. There are still large areas of the UK where there is no effective integration between bus services and rail services, or coach services and rail services. And that, if we're going to provide a coherent and attractive public transport system, we need to actually get all that integration, and with active travel, with cycling and walking.
It's the key thing. It's that integration.
And it means the rail industry has got to lift its head up a bit and stop obsessing about internal things for a little while, and actually look at where rail sits within the wider transport architecture, and to take a case to government jointly with some of the other transport modes.
Absolutely.
And the data, the really frustrating thing is, I think the data exists, because if the highways, national highways, have traffic monitoring cameras all over the nation, and they actually track vehicles, but they do it in a way that that means they don't track your speed, but they do actually track vehicle flows. So they've got a huge amount of origin and destination data.
We know what that picture needs to look like, really. Yeah.
And we could use that to say, well, which flows? Are there flows out there that are better suited to rail? Are there flows out there where a bus service would actually? But we're not doing any of that.
Yeah. And it's funny. You're presupposing several chapters in my book, but let's not talk about that. So I think the key thing for us to conclude, I will throw out, if if we want any, is there a quick question from the audience? Is everyone fairly satisfied?
Just one. I mean, it's certainly not my specialist subject at all, but I know we're considering it because of ISO and the question of climate change is coming to that impact our business. But in East Anglia, my brother-in-law's golf course set up a reservoir for runoff because it's not about drainage. It's in some stations it's in storage.
Yeah.
Yes.
Considering that as well and saying, you know, what farms, what golf courses, what
Yeah.
could use that water, and is it mini reservoirs or is it attenuation tanks or is it anything like that that we can do? Because even in my neck of the woods, you know, farmers are still, you know, in the East Coast certainly are certainly looking for water at some stage of the season.
So I'm conscious that wasn't mic'd up, so I'll just very quickly paraphrase that as a question, and Stephen, you and I can both kind of tackle it. It was about water and about what happens to the water as it's come, as we've collected that water and we built a drainage system that does collect the right amount of water to mitigate the flows into streams and stuff. What do we have opportunities to do that water? It's a good microcosm of other things as well.
Yeah, I mean, I think, yes, there are opportunities, and you know, a lot of drainage schemes have attenuation tanks, balancing ponds. They are an integral part of the scheme, and there is the question of what you might be able to do with that water. The problem with water from road runoff, and maybe to a lesser extent with rail runoff, is the materials that are actually carried in the water. So, you know, a lot of iron filings in railway.
Yeah, but the opportunity there is to clean that up and use it.
Yeah,
Absolutely.
yeah. So yes, basically.
Yeah.
I mean,
I was going to say, I think the answer is yes.
So there's definitely a role there, a part that can be played by rail drainage. But also, interestingly, in Transport for London, the ballast structure itself, in certain parts of the network, acts as an attenuation tank. The drainage is planned on the basis that the ballast will become waterlogged and will store a certain amount of water that will then take a defined time to run out.
Certainly something for certainly good food for thought, and an interesting microcosm of all the various questions that get raised. I'm going to draw us to a close there. Thank you again to Pandal, but Stephen, thank you so much. That was
thank you, Gareth.
A fascinating conversation.
It was very interesting.
See you for the next session. Well, there's primary engineers in here next, but see you for the next session.
Thank you.
Cheers, all.